Hello everyone, welcome to this set of lecture where we are going to discuss about the pointers. In this series we are having three parts of lecture. In the first part we are going to discuss about the definition of the pointer, uses and arithmetic, that is the pointer arithmetic. Then we are going to discuss about the double pointers, and then we are going to discuss the null and the void pointer. So pointer, as we all know, that it is a feature, it is one of the most important feature in the C programming language. By definition, it can be said that it is a variable which can hold the address of a variable or a function of the same data type. Here you need to consider that you need to focus on the term the same data type. So a pointer data type should be same as the variable data type. Otherwise, it cannot store the address of that variable. As we all know that the address is an unsigned integer value, so pointer is actually storing an unsigned integer value. As the pointer is going to store always an unsigned integer value, irrespective of the type, its size will be the size of an unsigned integer. Depending on the compiler, the unsigned integer can be of 2 byte, 4 byte or 8 byte. Pointer is basically a variable, so if we want to print the value stored in that variable, that pointer variable, we must use the %u format specifier, which is for the unsigned integer, format specifier for unsigned integer. And then we can declare the pointer by using the data type followed by asterisk followed by the pointer's name. So if we want to declare an integer type of pointer, then we should write int, that is the data type, star, and suppose the pointer name is p1. Similarly, if we want to declare a floating type of pointer, so it will be float star p2. Now, though p1 and p2 are integer and floating type respectively, but in both of the cases their size will be same because it is a pointer, and pointer size will be always at the same size of a unsigned integer. Now, how to use a pointer? Now, first of all, how pointer is storing the address of a variable or a function. Now, how can we get the address of a variable? By using the address of operator. The and symbol is used for as the address of operator. So, by using this address of operator, we can get the address of a variable. Then we can assign that address into a pointer. Now, if we want to access the value stored in that variable, then we need to use the asterisk operator. So let us understand this. Suppose a is an integer type of variable having the value 10 and p is a integer type of pointer. So we can write p equals to address of a, because a and p both are of integer type, so we can store the address of a. Now if I print the value of a, it will print 10. Now if I want to access the value of a using p, then we need to use asterisk p, and this will give me the value 10. So this asterisk operator will be called value at the address of. So this is actually what I am saying, value at the address. Which address? The address stored in p. So it is 10 because I have assigned the address of a into p. So let us consider a code, and that will give you a better idea about this. Consider this code. Here we have a integer type of variable a having a value 10. Then I have a pointer p, and I have an integer type of pointer q. Similarly, I am having a floating type of variable b having the value 10.0 and the floating type of pointer r. Now, Let me first compile this code, and this code at this point will give me an error, and the error will be at the line number 9. So you can see that it is giving me a error in the line number 9. Why this is an error? Because q is a integer type of pointer, and I am trying to assign a floating type address of a floating type of variable into q, so which is not possible, which is not permissible, because a pointer can store the address of a variable of same data type. So as this cannot be done, let me comment out that line and recompile that code, and this time it will not give me any error. So in this line, what I am doing, I am putting the address of A into P. So if I put address of A into P, then P is holding the address of A, and to access the value of A using P, I should use star P. Now in this printf statement, as I have already told you, that both of them will give me the same size for P or R, though they are of different data types. Next, in this line, I am printing the address of A, and in the second line, in this third printf statement, I am printing the value stored in the pointer P. So as P is holding the address of A, these two statements should give me the same value for address of A and P. Next, I am printing the value of A, which is 10, and then I am printing the value pointed by the pointer P by using this asterisk operator or the value at the address of operator. Next, we are printing %p equals to asterisk address of A. So you can see that the size of P is 4, size of R is 4. They are same because they are both unsigned integer value. They are storing unsigned integer value. Then address of A is 6422164, which is stored in P. So P is having the same value. Now value of A is 10, and the value pointed by P is also 10. Then the last printf statement is giving me 10 equals to 10. So let me explain the code in details. So what is happening in this code, that we are only using the pointer P and the variable A, so we are going to consider only those two variables. So as A is a variable, it will be stored in the memory, and in the memory it will have an address, a particular address where it will be stored. So let us consider that the address is 1000. So at the address 1000 in the memory, a variable is stored and its initial value is 10. Next, P is a pointer which also be stored in the memory, and suppose its address is 1004. Now P is holding the address of A. So P is holding, what is the address of A? 1000 is the address of A. So P is holding their 1000 value. Now as it is holding the 1000 value, actually it is pointing to this address in the memory. That is why it is called pointer. And now as it is pointing to this, the asterisk P, that is value at the address of the value of P 1000. So asterisk P means value at the address 1000. What is the value at the address? That is 10. Right? So that is how the pointer is used, or point to the address, and by using this asterisk or value at the address of operator, we can access the value pointed by the pointer. Now let us come to this notation, this syntax. So value at the address, which address? Address of A. So this is the address of operator. So address of A is 1000 for our example. Now as this is 1000, this is pointing to 10. So that is why we are getting star P equals to star address of A. Now next we are going to discuss about the pointer arithmetic. For understanding the pointer arithmetic, let us take an analogy. Let us consider this: in this road there are some same type of houses are there, and both of the houses having a number that is their address. Like all our houses having a street name and the street number. So this is the street and this is the number of the house. Each of them are having same size, right? So they are 1 unit apart. Now, considering this house, what are the permissible question I can ask from this house? What I can ask? Which house will I reach if I start from the house number 101, means this house, and move 2 units towards right. So from here, if I move 2 units towards, which house should I reach? So I can answer that I am reaching 1003, right? Right side means I am adding. Come to the third question. So question is, which house will I reach if I start from the 1004 and move 3 units towards left? So I am starting in this position and I am moving towards left by 3 units. So I can reach to this house. So this question and this question is answerable. Let us take the second question. How many houses are there in between 1002 and 1004? My answer will be only one house, that is 1003, this house. So this question is also answerable. Now, if I ask you which house will I get if I add the house 1001 and 1003, this will give me no answer, because by asking or adding these two houses, I will reach nowhere in the road. So this question is not a valid one. So let us ask another question. Which house will I get if I multiply 1001 and 1003? Multiplying two house number will not give me any house number because the road is over. So that is, it is not a valid question. Similarly, if I divide the house number 1003 and 1001, that will not give me any house, because house number cannot be in fraction in this case. So this is also not a valid question. So the valid question are these three. When I am adding a particular or adding or subtracting a integer value or some integer value to the house number, or I am subtracting a house number from another house number to get how many houses are in there in between. Now these three questions are answerable. So using that same logic, we are going to consider that houses, each and every houses is actually in a memory block, and this road is the bus where the memory is connected. So using this analogy, let us see what are the pointers arithmetic are possible and which are restricted. So permissible pointers arithmetic are adding and subtracting an integer value to a pointer. So the question number 1 and question number 3 is actually adding and subtracting an integer value to the address respectively. Similarly, now how the addition and the subtraction will work in case of pointer. Let us take P is the pointer and I am trying to add an integer value I to that pointer. So the final result P plus I will be P plus I into size of the data type. If P is integer, then P plus I will be P plus I into size of the integer, and that size of the integer will depend on the compiler. Similarly, if I subtracting an integer value from the pointer, then it will be P minus I into size of the data type. So in our coding example, as we considered, the P is holding the address of A and that is 1000. So P plus 1 will give me 1000 plus 1 into size of integer. If the size of integer is 4, then it will give me 1004. So if I perform P minus 2, considering P value is 1000, so this will give me P into P minus 2 into 4. We are considering size of integer is 4. So this will be 992. Now this is how a pointer can be, integer value can be added or subtracted from the pointer. We can subtract a pointer from another pointer if their data type are same. If their data type are not same, we cannot perform the pointer subtraction. So let us consider P and Q are two same type of pointers, then P minus Q will be P minus Q divided by the size of data type. So let us take here, considering the same example, let us take, we have written Q equals to P plus 2. So what will be the value of Q? Q value will be 1008. Now if we perform Q minus P, that time it will give me, remember P and Q are the same data type, so 1008 minus 1000 by size of int. So this will give me, considering the size of int is 8 and size of int is 4, we are performing 8 by 4, that is 2. Why we are dividing the size of the data type? Considering this example, what we are actually finding in the question number 2, how many houses we can allocate in between these two, 1002 and 1004 houses. As they are all of one unit, we are actually subtracting and then dividing by the size of the house. So that is why we are finding that how many same type of variable we can allocate in between these two variables. Now for this same example, the P minus Q will give me minus 2. You can understand why it is giving me minus 2. So what are the restricted operation? Addition of two pointers, maybe they are of same type, maybe they are of different type, but addition of two pointers are restricted. Next, multiplication of pointers or pointer with any kind of value is restricted. Division of two pointers or dividing a pointer by any other value is restricted. So let us go for a code and try to understand how it is working. So in the second code, what we are doing, we are assigning, we have already discussed that one. Then we are assigning the P equals to address of A, then Q equals to P plus 1. Let us make it P equals to Q equals to P plus 2. Assigning the address of B into the pointer R. R is a floating type of pointer, so there is no harm in this assignment. Now this printf statement will give me an error in the line number 12 because R is a floating type of pointer and P is an integer type of pointer. We can subtract a pointer from a pointer when their data type is same, but here the data type is not same, so this will give me an error. So let us first compile this code and see. We are getting an error in line number 12 and it is showing that this is not permissible. So let us comment it out, and the rest of the 3 commented lines will also give me error because addition of 2 pointers is not permissible, multiplication of pointers are not permissible, and division of pointers is not permissible. So let us take permissible operations. Address stored at P is equals to %u, that is we are printing the value of P, and Q is we are printing the value of q, and we are printing the size of the integer pointer. Now this will give me 4. So let us remove this part, it is not required here. Now this will give me, if depending on the value of p, q should be 8 more than the value of p. We are going to see that in the result. Then p is equals to percent of that is, we are printing the value of p, then p minus 1 is, we are performing p minus 1. This p minus 1 value should be less 4 than the value of p, as the unsigned integer size is 4. Then q minus p, this will give me 2. So you can see that p value is something and the end is 60, and q value is 8 more than the value of p, because we have added 2 to that value of the p. Similarly, p minus 1 is less 4 than the value of p, because we have performed p minus 1. Size of integer in this compiler is 4. Now p minus q is 2. You can understand that this will give me 8 by the size of integer, that is the 4. So it will give me 2, and r equals to something 56, and r plus 1 is equals to something 60. So this will give me, why I am getting 4 more than this, because the size of float in this compiler is also 4 bytes. So I am getting the output which I am expecting. Now next, let us discuss the concept of double pointer. What is a double pointer? A pointer holding the address of another pointer of same type is called a pointer to n pointer or a double pointer. So first of all, both of the pointer and the double pointer have to be of same type. And generally we can declare how double pointer by this declaration, data type followed by star star. Here, as it is a double pointer, we need to use 2 asterisks followed by the pointer name. Now let us take how it is working. Suppose integer a is having value 10. Then we are declaring another pointer star p another pointer star p and a pointer to n pointer, that is asterisk q. So q is a pointer to n pointer which is of integer type, and p is a pointer which is integer type, so it can hold the address of an integer variable. So obviously I can write address of a for p, and I can write q equals to address of p. As it is a double pointer, q is a double pointer, then q can hold the address of another pointer, and their data type is same, you can see that. Now what is happening right here is, this is my memory allocation for a. Suppose a address is 1000 and its value is 10, what we have assigned. Then there will be another memory allocation for the pointer p. Suppose its address is 1004 and it is holding the address of a. So it is holding 1000. The address of a is 1000. Now by this, what I am saying? I am saying the code is pointing, the p is pointing to this memory location, right? Now q is a pointer to n pointer, so q is being stored in the memory, and suppose address is 1008, then it is storing the address of p. So what is the address of p? Address of p is 1004. So this is pointing to this one. Now if I print the value of a, so what it will print? It will print 10. Now if I print star p, value pointed by p, how much it will print? It will print 10. And if I print the value of p, I will get 1000, right? Now, if I print the value of q, what should I get? I will get 1004. Now, if I print star q, then value at this address, that is at the address of 1004, what is that value stored over there? I am storing 1000. Now, if I write star star q, what will happen? Star q, this will be like this. Now this will give me 1000, this part will give me 1000, so I will get 1000 star 1000. So star 1000 is the value at the address 1000, which what is that value? From here we know that it is 10, so I will get 10. So using the double pointer, that is how we can get the original value of the variable. As there is a double pointer or pointer to and pointer, there is a concept of pointer to and pointer to and pointer. What is that? It is a pointer which can store the address of a double pointer, and in that case we have to use asterisk 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 followed by the pointer name. Similarly, there is pointer to and pointer to and pointer, and this will continue, and we have to increase the number of asterisks when we are declaring that variable. Now let us verify our discussion. Right? So here what we are doing, I am having an integer variable a, assigning it value 10. Then I am having an integer pointer p, and I am having a double pointer q of integer type. So p is holding the address of a, and as q is a pointer to and pointer, so it can hold the address of p. So it is holding the address of p. Now the address of p is in, we can use this address of operator. Similarly, as q is holding the address of, we can use and if we print the value of q, these two value, this value and this value will be same. Similarly, address of a we can access using the address of a operator, and as it is stored in p, so we can use this one. And the star q, here we can see that the star q is giving you the address of a. So here we are getting the address of a. Now to get the value of a, we can use the name of the variable, that is a, or address value at the address of stored in p, or we're using the double pointer q. So let us first compile this code, and so you can see that address of p is similar to the value of q, address of a is similar to the value of p, similar to the value pointed by q, and value of a is similar to the value pointed by q and pointed by p. Value of a is 10, which is similar to the value pointed by p and the value pointed by the double pointer q. In this way we can use the double pointer. Now in the next part we are going to learn what is a null pointer and what is a void pointer. A null pointer is a pointer and it is having a particular data type. So a null pointer should have a data type like integer, float, character. In this example we are using integer, so ptr is our null pointer and it holds the value null, that is 0. So as it is holding the value 0, it is pointing to nowhere. As it is pointing to nowhere, we call it as a null pointer. This null pointer will give me a significant information or play a significant role in the function which are returning a pointer like fopen, that is to open a file. We are going to learn that later. And strchr, this is to check a character is present in a string or not. Now these two functions returns a null pointer or null value to a pointer when there is some issue with the proper running of these two functions. Void pointer does not has any particular data type. As it does not have any particular data type, it can hold any proper address of any type of variable. Maybe the variable is of integer type, it can be of float type, character type, double type, whatever the type it is. A void pointer can hold the address of that kind of only kind of variable. But to use that address, we need to typecast it. So without typecasting, we cannot use the void type of pointer. And this void type of pointer plays a significant role in case of the functions, mainly in dynamic memory allocation, calloc and malloc. We are going to learn about this calloc and malloc function in details when we are going to discuss the dynamic memory allocation. Now, how we can declare a void type of pointer? The data type is mentioned have to be void, then asterisk for pointer, then the name of the pointer. So that's it for today's video. In the next video, we are going to discuss about how we can pass a pointer to a function and how a function can return a pointer to the following function. Now, after that, we are going to discuss how a 1D array can be realized using the concept of pointer. So, till then, stay safe and see you in the next part of the video.